So here we go. For this kite, you were given a bunch of dimensions, and you want to solve for angle A here, of course, and it's side, side, side. No surprises there. I want to find that angle. I make sure that the side across from that angle is here. I enter it. I get a negative, which should tell you it's going to be an obtuse angle. You take the inverse of that. Make sure you don't mix up sine law and cosine law. I have some students write the whole thing out with sine of something, right? This definitely doesn't look like sine law, right? Sine law is when you have your pair. And so this should have been 111.8 degrees. 111.8 degrees. If you don't do the negative, you actually get an acute angle, right? You get actually the supplement of this. So 180 minus 111.8, that's what you probably got. That's what you got if you did everything else right. That would be a -1, okay? If you forget the negative, that would be a -1, even though you did everything else right, so watch out for that. Then it's asking to find the measures of angle B and C. And notice what I do. I switch over to sine law just to show you that that works, right? So now that I have that angle, 111.8, 10, I set it up like this. And you can pick which one you want to find. I chose B to solve for B. If you want to solve for B, make sure this side is on the bottom here. And this is a cross multiplying and dividing scenario. You take the inverse sine, and then you get 27.66, and then I use sum of triangle to get my third angle. Okay. Now, of course, if you made a mistake in the first one, it's going to carry over. You would still get, in my books, you would still, if you did everything else right, 1.5 here for that work. You would still get full marks for everything that follows, right? And that's how I mark it, and that's how they train us to mark, right? Because you shouldn't penalize you for, if the work is consistent and correct, you know what you're doing, right? You just made a mistake up higher up. Sometimes, though, the mistake causes you to have errors down the road. Your calculator actually might complain and say it can't do it, right? So you got to watch out for that. You could have used cosine law over and over, right? You could have used cosine law to solve for angle B and do it that way. That's fine, okay? So this page was worth 4 marks. If you did it all right, you get 4 on this page. And then on the back side, I kind of went over it already yesterday. I'm gonna just show you here. I don't know if you want to take a moment to just copy, but I start with my diagram, right? That we're starting here, and you're going south 15 west, right? So you're traveling 13 kilometers, and then you refuel. And at that point, you're going west 10 degrees south. You're going this way. And I think what a lot of you missed is that there's actually a 90 here. So you actually, if you add up these 3 angles, you get your and some of you were thinking it has to be something with 180, not necessarily, because if you look at this side and this side, it's not a straight angle, right? But it's an obtuse. So that getting that angle that you're missing when I didn't draw my clean one on this. This is my key here. But yesterday I showed you, right, that I would suggest you draw your story, then you do whatever you need to do in this diagram, right? Bring stuff over, but then make your clean version outside, right? Because this is too busy. There's too much going on. And then you see, okay, there's the 115. I got it from this here. And this called for cosine law, right? And when you do all of that, you get 19.46, which is, here's the actual work. I don't know if you want to take a moment to write that down. At least write down the answer so you can work backwards, right? And see if you can do that. That was one of my strategies. If I didn't get it right, I look at the answer and then I'm kind of trying to figure out, okay, like how was that answer, calculated, right? Like I would work backwards and see if I can somehow make that work, and then later read the question again and then find out, oh yeah, I missed that 90, right? So there you go. And then 3, the search and rescue helicopter. That one I was actually very happy. Like a lot of you got the 76. A lot of you. What I didn't like is that someone made that 25 appear here, or you went 90 minus 25, right? 90 minus 25 to get that. There's no 90 there, right? Like you don't see it there. There's the 90 would be with respect to the east-west line. There's a 90 for sure, but you can tell that it's not, right? And you know why? That's why I'm telling you, wherever you end up, don't make it line up with your starting point, because then you'll be tempted to see that 90 there, right? And it's really not. It's not there. Okay. And let me show you the work. If you're writing this down, basically you start off with your sine law here, and the ultimate question is here to find this, right? This side here. And from the turning point to your final destination. So the only thing that I can do at first is to solve for this angle here, right? And if you do that using sine law, you get 35.6 degrees. Oh. Thank you. I'm so into this that I don't even notice that. So we solve for angle F using sine law, we get 35.6. And then I use sum of triangle to get this angle, which in turn is going to allow me to solve for that side across, right, which is 71.87. And if you look at it carefully, the total distance traveled, it doesn't say that you're going back from your destination, right? It doesn't. So you're basically flying from here to here, and then from here to there. So what's the total distance traveled? You just add up these two here. Which for me right now, if you added all three, that was just a half mark deduction in my books. Like it's not the end of the world. It wasn't very clear. But so it's not 191, it's 116, because you just add up these two sides here. Okay. Not returning to starting point. Now you have it. And then I will give you a little overview now as to what can you expect on the quiz. All right. So let me see if there's a slot in your books that I can fit this into. So if you grab your books, because you're going to need them anyways. I think at the back of the book, I always leave a few empty pages there. Yeah. So if you go all the way to page 51, at the back of 51, there's a blank space there. Okay, trig review in a sense. Okay, know how to solve for sides, angles, given a diagram. Anywhere in the back, any blank page will do, okay? If you're wondering what's happening, that's fine. Right, so you have your, if you have a pair, use sine law, right? Side, 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 and side angle side, you use cosine law. You should have these on your on the study sheet for sure. Okay. Word problems. And I want to be careful with this because I don't want you to think, oh yeah, this is everything that could possibly be thrown at me. I don't want you to think that, okay? But the three main categories you will encounter is problems with oblique triangles, and that is just your normal, right? Like you read the story and it's telling you, hey, there's two wires, there's an angle with 60 here, the wires are 50 meters apart, and one of the wires is, let's say, 30 meters, right? Calculate this angle there. So that's just a plain old, you read the problem, you know where to put your angles. It's as simple as that. And then you will have the second category. You'll have problems with right triangles and oblique. If you're wondering what an oblique triangle is anything that isn't a right triangle, we call it oblique. We put it in the category of oblique, right? So when would you encounter something like this? You could have it, you want to look for angle of depression or angle of elevation. If you have something like that, you get that there's probably going to be a right triangle formed. So one of the scenarios could be like this, right? You have a tree or a tower, or you're looking up at an object, right? So there's that, it's angle of elevation. And then perhaps you move closer, or there's somebody closer to it, right? Looking up as well, there's your angle of elevation there. And obviously, there's the resulting height of the triangle, right? So that's the height, which makes a 90 with the ground. Okay. Extract two right triangles, perhaps. Right? You could have the big one there, and you could have the one that's closer to the tree and then work with it, right? Do you remember what we do with this one here? Like sometimes you want to work with this triangle here. This is the oblique, right? This is the oblique triangle right here. Sometimes you want to work with that, okay? This angle right here can be found by going 180, right, minus angle, right? Because they're supplementary when they're side by side. So when you have angle of elevation, you can take advantage of that. Go ahead. I don't have room. Well, I could probably do that, right? This would be a problem with angle of elevation. Okay, and then you would have a problem that perhaps, do you remember the angle of depression one that I made you draw on the AC, and actually you got it right, even though you thought you had it wrong? But if it's angle of depression, You remember it has to be with a horizontal, right? So let's say the scuba divers, I'm thinking of that question, and they spot a shark, right? And then you have this and this, right? You might have this angle and that angle given, so I just go check, check. And they might tell you that there's a height or a depth in this case, right? There's the depth. Or a plane is flying at a certain height. Nevertheless, right, this is your height. And remember, heights are key. They're key for knowing that, oh, that's a right triangle if I insert it into that, right? So you have this or this. Okay? But you notice what I'm doing with my red pen here? I'm showing you the oblique triangle that is also there. Okay? So in this case, never forget that you could work with the whole thing. Okay? You could still work with the whole thing. Let's do this. I will underline oblique with that. With whatever I used to go around the big triangle, right? So there are right triangles hidden within the oblique triangles, right? And don't be tempted to consider everything a right triangle. Okay, it has to be only if it's a height involved or something like that. And I could ask you for a bunch of things. I could ask you, hey, how far apart are the scuba divers? You might want to solve for this, and then solve for this, and then add them up, right? So honestly, I cannot go over every single scenario, but you know your tools, right? You always have sine law, cosine law to help you out. So category 1 is just plain word problems. That was one of the first things we did. Then we tackled the ones that have right triangles. And what's the last one? The one you love, right? Keeps you up at night. Those are the compass directions, okay? And I don't think so this is the second type, and here's the third type going on to my next blank page. Problems involving compass directions. Okay. I would say this: draw story, right? And then draw clean triangle. Usually only one angle given. Usually only one angle given, okay? And I wonder if I should just use one of these problems here. Nah, I'll just leave it. We're gonna do more today, so that's basically the heaviest part is gonna be on word problems, and that's I think I'm gonna do that right now. I reserved one of the pages for that extra word problem that I wanted to cover. So we're going to go back in our booklets. Okay? We're going to go to page 27 now. How about this? We say here, example, page 27. Okay? If you want an example of another, so let's say you're reviewing for the exam and you're going through this, and you're like, oh yeah, I want to look at another one. That's what we're going to do right now. And it's based on the textbook, by the way. But I'm going to change it up a little. So go to page 27, and you're going to have to write some of this down. Okay, so on page 27 in your books, right? A radar screen. A radar screen at a control tower shows two airplanes at the same altitude. Same altitude, same height, right? According to the radar, plane A is 100 kilometers away in the direction north 60 east. I'm going to change it up. North 55 east. Plane B is 180 kilometers away in the direction south 65 degrees east. A, how far apart are the planes? If both planes travel at the same speed, which will arrive first? I'm going to zoom in a little bit. And if you can't read something, just ask. Okay? If you're not sure about a just copy this down on page 27. And right now, give this a try. And I will look for a different one in the meantime. Anybody have a question from the review C? Bridget, you have? Is it the compass direction one? I hate those. Don't give me those. One of the ones where you can't assume you line up perfectly. If we went clean, actually line up perfectly. And Oh, yeah. On the good one. Transfer step over, you should see how you can come up with that. Oh, you just, oh, okay. Got it. Yeah, sorry. This is good. So there's a 40 and an 80 there. So there's an outside for traffic. Where your path is defined that inside. 180 minus the two that are outside is the inside. Well, the 40 you can't bring into because remember we measure this the 40 is between this top, which is the northern part of our triangle, right? Your line is here. The 40 is not there. The only one that you will know is right, the 40 is only like help you find. a bit, okay? Okay. I want to do a height one. That's why I'm pushing a little bit. Okay. The dreaded height, which is not really, you should be used to that. You've done right triangles a lot in grade 9, 10. Did you do trig in grade 9? Some of you do, some of you don't, right? That was COVID, right? That's probably when COVID, you were no, you're not the first group. The ones that are in grade 12 right now would be the first group affected by that. Which page did I make you do now? 24. So let's look at 24 here. You know, I have to take my hat off, like you're trying, right? Even if you make a mistake, you're not going to give up. You're not going to say, I just don't know how to do it. That's just me. I'll never get it right. Don't think like that. You'd be surprised how many marks you can still get, right? If you follow through the steps and you do everything you need to do, right? Okay, so here we go. Maybe, I'm just thinking right now, drawing your east-west line and your north-south with a different color, because then it will stick out a bit more. So we leave a dock, right? East, 40 south. So I'm here, I'm going east-south. So I'm gonna do this for us here. East-west line, this line, I'm gonna make it a different color, right? So you can tell that I'm starting here, this is my dock, I'm going 40 south, right? So I'm going in this direction. So that's 40. Okay? And I'm going for 3 miles. Okay. There we go. That should be pretty straightforward. It turns, so there's a point where you're turning, and then heads east 80 north. So I'm going to make my east, actually I'm going to go a little bit back and a little bit forward, but that's your east-west line, right? So you're going east 80 north. So you're actually turning north here. Temptation is to, I'm going to make it line up perfectly like that. That's just the way I like it right now. Don't do it. And 2 things, 5 miles, right? 3 miles. But even if you made it shorter, I would prefer that than you lining up. Don't line up, okay? So I'm going to go past it. And so this is my current position. So this is the 80 right there. And see how the red lines stick out, right? So I don't know if you want to do that, but the 40 comes in here, right? Alternate interior. And that will allow me to find this angle. But so I'm going to make my clean version here. You can close this if you want with a dashed line, right? But a different color tells you don't put the 40 in the triangle that you're about to draw, right? Doesn't it? I think to me, it really shows that you can't do it. So there's your dock, turning point, current position, right? The 40 is between the red and the direction, so I can't put that in here. But I can use these two to help me find this, right? So 180 minus 80, that's 100, minus 40, happens to be 60 again, lots of 60s, right? So that would be good. And then the 3 and the 5 come in here, and SAS, right? So I'm going to call this lowercase t. How far are you currently from the dock? So whatever letter you gave it, just stick with it, right? So 3 squared, 5 squared, minus 2 times 3 times 5. And I'm going to ask you for the answer here, if you don't mind. Isn't this exactly 19? If you did it, I get some nods. I'm going to go with it, guys. I'm going to trust you here. And this is 4.36, and we're in miles. There you go. Not too bad, right? So sometimes they're a bit more straightforward, sometimes a bit more complicated. Just make sure you don't assume things are in there. 99% of the time, there's only one angle in that resulting triangle. Even though you've got two angles in the question, they're usually there. Sometimes it will transfer in partially. Sometimes it will transfer outside, but it will help you find the inside, right? So just be careful when you draw your triangles. Okay, and I'm thinking I'm gonna do that problem right now that you were talking about. So if you have your workbooks, trig C review. I had a different one lined up, but apparently this one didn't make it to the answer key. So I will do two things. I will go over it here. So on page 11 of your workbook, but I don't want you to just randomly have that there. I'm going to go in our booklets and I will do this here. If you go to your notes on page 21, okay, more, right, page 11 of the workbook. If you want another example that deals with height, this is where you would find it, right? So that you cross-reference. And I will try to do a better job next time at just putting all the workbook inside the notes, not so that way you don't have two different books. So if you want to take the course again next year, you are more than welcome to do that. You wouldn't want to do that. Right? Okay, an airplane is spotted between two observers. On the ground, the observers are 1,500 meters apart. One observer spots the plane at an angle of elevation. There it is. That should be like, okay, this is going to have some right triangles in it, perhaps, right? Of 83 degrees. They're 1,500 meters apart. This is on page 11 in our books. The other one spots the plane at an elevation of 68 degrees. Determine the distance from each observer to the plane. This is the last example before tomorrow you're on your own, guys. So two observers, one here and one is they're 1,500 meters apart. It says that the airplane is spotted between the two. My diagram is going to be a bit small. Let's make it a little bigger. Between the two, we're told clearly that this is like this and the plane is somewhere in here. It is closer to one versus the other. So I'm going to do this. And they're on the ground, so we can assume that they're perfectly aligned. This is observer A, observer B, and I'm going to call this P for plane. And then there's my triangle. This is actually one where you have your oblique mixed in with your right triangles. So this one would be 83 here in my books. This one would be 68. And this is 1,500 meters. It doesn't ask for height. I would have definitely been tempted to ask you for the height here. But you can definitely find angle P, so I'm going to go for it. And I'm going to have to, because apparently this is not in my answer key. I don't know what happened. So P is 29, so then you have a pair. I'm going to review how to find the height though, real quick. So this is my pair, so sine of 29 degrees. We haven't done a whole lot of sine law lately, right? Sine of 29 is equal to, you decide if you want to find A or B first, right? So sine of 83 over A, you do the work. Please show me the work, okay? Don't go choo-choo train. This equals answer. Don't do that. It's not going to go well for you, okay? Is he threatening us? No, but you'll lose some marks. Okay. 3.0, sorry, not point, just 3070.94, and that's meters. So this is distance from, this is actually, if you find sine A, you're actually finding the distance from person B to the plane. And then we'll do the same thing again. Same thing again. Sine of 68 over side B. Remember, it's always across, right? That's the pattern. I will skip this step and just give you the answer. (28, 68, 71 meters). Okay, which makes sense. Smaller angle should be shorter side. So that's that. How would you find the height? You remember how to find the height? You remember the shortcut? Anyone? How to find the height of a triangle? The height is, yeah, you either take side B times sine of 83, or you take side A times sine of 68. Do not use 1500, right? Because it's perpendicular to the height. That wouldn't work. It has to be one of the slanted sides. Okay, so height would be 28, 68, 71 times sine of 83. That's 28, 47, 33. And I'm gonna give you NAC to practice for the quiz. Okay, it's actually probably an old quiz anyways.